let's explore how graphs of inverses are related to the original functions. So let's go ahead and graph ourselves a one-to-one function. Include a scaling, label our axes, and I think my graph will go through -1, -2, 1, 1, and 2, 3. And I think I said -1, -2, but that's clearly -2, -1. We'll go ahead and I think I'll make it go through the origin as well. And I'll connect these with a smooth curve. Remember, whatever curve I draw has to pass the horizontal line test if I want my function to have an inverse. So I'll make sure it does that. And now I'm going to go ahead and find some points that lie on the graph of the inverse function. The way I'm going to do that is I'm going to observe. Let's start with this rightmost point. I'm going to observe that 2, 3 is on the graph of, let's call this f of x. And what this means is that f of 2 is equal to 3. So if I want to know a point that's going to be on the graph of f inverse, I just switch the inputs and outputs, and I know now that f inverse of 3 is going to be equal to 2. And I'll go ahead and include that, or perhaps more accurately, I'll go ahead and fill that as a point for my f inverse graph. And we can do this for other points too. So f inverse of 1, excuse me, not f inverse of 1. What I want to say is 1, 1 is on the graph of f, so that means f of 1 is equal to 1. And so if I switch 1 and 1, well, that doesn't really do anything. I have that the inverse of f at 1 is 1. So I'll go ahead and include 1, 1 on my graph of the inverse. To be able to shortcut this a little bit, notice that this 2 was the x-coordinate and this 3 was the y-coordinate. And what happened was that y-coordinate became an x-coordinate for the inverse, and that x-coordinate became a y-coordinate for the inverse. So in essence, if I notice that -2, -1 is on the graph of f, then if I just switch those, so -2, -1 switch will be -1, -2, then that will get me a a point on the graph of f inverse. Doing that the long way, we know that f of -2 is -1, so f inverse of -1 is -2. Let's try to estimate one more point that will be on the graph of f inverse. So right here, I have the point 1.5. This here is 1 and this is 1. 1.5, 2. So 2, 1.5 will be on the graph of the inverse. And I can even do one more. 0, 0 is on the graph of f. Well, if you switch 0 and 0, you get 0, 0. So the point 0, 0 will be on the graph of f inverse. And if I connect these, then I get a curve that looks like this. So if you have the graph of f, in order to graph the inverse function, all you need to do is find some points on the graph of f and switch the x and y coordinates. Now, you might notice that there is a bit of symmetry that's going on here. What's happening is the graph of the inverse function is the reflection of the graph of f about the line y equals x. So what I have here is the line y equals x. Maybe I'll do this in a different color here. So there's the line y equals x. And you notice that f inverse of x is the reflection. Oh, got a stray arrow. the reflection of f about this line y equals x.